Very good morning, all of you. In the last class, we have discussed that differences between the orbit and orbital and wave mechanical model. Next, I will be showing the equation in that. What is the psi? What is the psi square and important features of this psi and psi square we have discussed. So today we are discussing very important concept, that is a quantum numbers. So quantum numbers are precisely explain the about the atomic orbital. Precisely explain about the atomic orbital. So there are four quantum numbers are there. How many quantum numbers? Four quantum numbers are there. First one is a principal quantum number. First one, principal quantum number indicated with N. Second one, azimuthal quantum number is indicated with M, L, R, L. Next another one, not ML, is indicated with the L. Next magnetic quantum number, this is indicated with M, R, ML. Next another one, spin quantum number. So spin quantum number indicated with S, R, S. So first three quantum numbers, principal quantum number, azimuthal quantum number, magnetic quantum number, gives information about the atomic orbital, and spin quantum number gives about the spin of the electron. So first we will see one by one. First one, principal quantum number. What is that? Principal quantum number, that is indicated with the small n. Principal quantum number indicated with the small n. So principal quantum number proposed by Niels Bohr. Principal quantum number was proposed by Niels Bohr. It mainly gives information about the energy levels. It mainly gives information about the energy levels or shells. Energy levels or shells. So actually what quantum numbers explain. So suppose if you want to find any person, first what we will see. So first, in which country is present. So first after seeing that country, next we go for in which state. Yes or no? Which country, which state, which street, door number. So these are the ways to find or trace a person. So like that, if you want to find the electron, so we have to see that step by step, where we have to trace step by step. So first we are seeing the shells. So shells which are present around the nucleus, that we are called orbits. That we are called also orbits. So first, in which shell it is present. Yes or no? So and it also will give information about the radius of the orbit, and energy of the electron. So that n value here 1, 2, 3, 4 and so on. Is it clear? So by increasing the n value, energy of the orbit is also increases. E1 is less than, E2 is less than, E3 is less than, E4 less than, and so on. So energy of the orbit also increases, and as well as radius of the orbit is also increases by increasing the n value. That is a principal quantum number. Is it clear? So by using this one, we can find the number of electrons in the orbit. That is formula we have seen that 2n square. This is for number of electrons in orbit. What is that? In orbit. So this is the main information about the principal quantum number. So it is indicated with small n. So this was given by Niels Bohr. So it mainly gives information about the energy levels or shells or orbits. Is it clear? So now n value starts from 1, 2, 3, 4, and it is also gives information about the radius of the orbit and energy of the orbit. So by increasing the n value, energy is increases by increasing the n value, radius of the orbit is also increases. So by using this one, we can find the total number of electrons, that is 2n square. So total number of electrons present in orbit. Next another one, azimuthal quantum number. Azimuthal quantum number. This is also called angular momentum quantum number or subsidiary. What is that? Subsidiary quantum number. Subsidiary quantum number indicated with a small n. Indicated with a small n. So what is an azimuthal quantum number explains? So azimuthal quantum number was given by Sommerfeld. Given by Sommerfeld. So he tried to explain the fine spectrum. He tried to explain the fine spectrum. So, and also he has given about information about the subshells. He has given information about the subshells, and then azimuthal quantum number also explains the shapes of the orbital. Shapes of orbital. Is it clear? So azimuthal quantum number, the values are depends upon the principal quantum number. Azimuthal quantum number values are depends upon the principal quantum number. If n value is 1, L value is 0. If n value is 1, L value is 0, that is a S subshell. That is a S subshell. If n value is 2, L value is 0, 1. L value is 0, 1. So that is S P subshell. S subshell, P subshell. If n value is 3, L is equal to 0, 1, 2. Is it clear? So that is S subshell, P subshell, D subshell. So 0 for S, L is equal to 0, that is S. 1, that is a P subshell. L is equal to 2, that is a D subshell. That is a D subshell. So generally we can write that L values are 0, 1, 2, 3 and so on, n minus 1. N minus 1. And the energy of the orbital, in the azimuthal quantum number, the energy of the orbital S less than P less than D less than F. If they are having the same L value and different L values, for example 2s, 3s, 4s, like this. So by increasing the energy level, the shape of the orbital increases. The shape of the orbital increases, and the angular momentum of an electron is quantized. The angular momentum of an electron is quantized. That is L is equal to square root of L plus 1 h by 2 pi, or angular momentum, that is equal to square root of L plus 1 h cross. Here h cross is equal to h by 2 pi. H cross is equal to h by 2 pi. And now we will see the shapes of the orbital. First, if n is equal to 0, n is equal to 1, n is equal to 0, that is s orbital. S orbital is spherical in shape. S orbital is spherical in shape. Suppose L is equal to 1, that is a P orbital, that is a dumbbell shape, and L is equal to 2, that is a D subshell. That shape is double shape. So L is equal to 3, that is a F subshell, that is a 4-fold dumbbell or complex structure. 4-fold dumbbell or complex structure. So this is a azimuthal quantum number or angular momentum quantum number or subsidiary quantum number. So azimuthal quantum number mainly is proposed by Sommerfeld. We try to explain the fine spectrum. And next he has given information about the subshells. So first principal quantum number gives information about the shells. So next azimuthal quantum number gives information about the subshells. Next he has given the shapes of the orbital. He has given the shapes of the orbital. The values are depends upon the principal quantum number. The values are depends upon the principal quantum number. N is equal to 1, L is equal to 0, S subshell. N is equal to 2, L is equal to 0 and 1. That is equal to S subshell S. L is equal to 0, S. L is equal to 1, P subshell. If N is equal to 3, L is equal to 0, S, 1, P, 2, D. The values of L is equal to 0, 1, 2, 3 and so on, N minus 1. And the energy of the orbital S less than, P less than, D less than F. Next, if the orbitals or subshells, we have to speak about the subshells now. So if the subshells are the same but principal quantum number is greater, so the shape of the orbital is the same but size of the orbital increases. The angular momentum of an electron, that is capital L, is equal to square root of L plus 1 h by 2 pi, or L is equal to square root of L plus 1 h cross is equal to h by 2 pi. Now we will see that third quantum number, that is a magnetic quantum number. That is magnetic quantum number indicated with a m, small m or m l. So why? Because this magnetic quantum number value depends upon the l. So that's why you can use m l. Now we will see that magnetic quantum number. This was given by Landé, the scientist. Landé has given the magnetic quantum number. So magnetic quantum number explains the G1 effect. Explains the G1 effect and Stark effect. G1 effect and Stark effect. So what is the G1 effect? Splitting of spectral lines. What is that? Splitting of spectral lines in the presence of magnetic field. Splitting of spectral lines in the presence of magnetic field. That is called Zeeman effect. Next come to the Stark effect. Splitting of spectral lines in the presence of electric field. So these two are explained by magnetic quantum number. So G1 effect, splitting of spectral lines in the presence of magnetic field. You can remember M. G1 we are having M. So splitting of spectral lines in the presence of magnetic field, that is G1 effect. Splitting of spectral lines in the presence of electric field, that is a Stark effect. And magnetic quantum number mainly gives information about the orientation of orbitals. What is that? Orientation of orbitals. So the values of the m value, the values of the magnetic quantum number depends upon the L. So m is equal to minus L, 0 plus L. Minus L includes 0 plus L. So how the values you can see? L is equal to 0. For example, m value is 0. If L is equal to 1, m value is a minus 1, 0 plus 1. Is it clear? Suppose L is equal to 2, m value is equal to minus 2, minus 1, 0 plus 1 plus 2. Is it clear? M value is 3. M is equal to minus 3, minus 2, minus 1, 0 plus 1 plus 2 plus 3. Is it clear? So total number of orbitals, how we can calculate? By using the formula, we can see that 2L plus 1. This is a formula, it is used to calculate the total number of orbitals. Suppose n value is 0, 2 into 0, 1. So S subshell has the 1 orbital. If n value is 1, so 2 into 1 plus 3, so 3. So L subshell has the 3 orbitals. So like this, he tried to explain the orientation of the orbitals. orientation of the orbitals. Next, if L value is 1, so L value is 2, M value is equal to minus 2 minus 2 into 2 plus 1, 5. So L value is 3, 2 into 3 plus 1, 7. So like that, total number of orbitals you can calculate by using the formula L 2L plus 1. Suppose if you want to calculate the total number of electrons, so 2 of 2L plus 1, 2 of 2L plus 1. So this is a magnetic quantum number. So magnetic quantum number explains the mainly Zeeman and Stark effect. This was, and magnetic quantum number was given by Landau. So it mainly explains the orientation of the orbitals. It mainly explains the orientation of the orbitals, how they are present around the nucleus, how that shape, how that what we can say, how that probability, how the density of the electron is present. And next, m is equal to, the values lies between the minus L, 0 plus L. So L is equal to 0, m is equal to 0, L is equal to 1, m is equal to minus 1, 0 plus 1. In such a way we can calculate the m values, and total number of orbitals in that formula 2L plus 1, total number of electrons 2 of 2L plus 1 in the given subshell. Is it clear? So first we have seen that shells, principal quantum number. Second we have seen that subshells. So third one we have seen that orbital. So electron present in the one particular shell into that subshell in that orbital. So these three mainly explains the atomic orbital precisely. Next one, fourth one, spin quantum number. Next, fourth one, spin quantum number, that is indicated with small s or ms. So this was given by Uhlenbeck, name of scientist Uhlenbeck and Gauss-Smith. They tried to explain the splitting of the spectral lines. So how that splitting of the spectral line occurs if you observe with the high resolution spectroscopy. So for that they are given that few important things regarding the spin of the electron. So while electron revolving around the nucleus, how electron revolves around the how that planet, you can say how that our earth revolves around the sun, like electrons also revolves around the nucleus. So while they are rotating, what are the electrons rotating around the nucleus, they can move along themselves. Is it clear? So they can rotate along their own axis. So if electrons rotates along the clockwise direction, in a clockwise direction, that is called plus half. They are given as plus half. If the electron revolves around the nucleus and revolves around itself anti-clockwise, then they are given minus half. So because of the clockwise and anti-clockwise directions of the electron, we are getting the splitting of the spectral lines. And while that electron revolving, that angular momentum is also quantized. That is spin angular momentum. That is mu s is equal to square root of s plus 1 h by 2 pi. Square root of s plus 1 h by 2 pi. That is mu s is equal to square root of s plus 1 h cross. Or we can write square root of s plus 1 h cross. H cross is here h by 2 pi. While electron revolving around the nucleus, we have said that it may move in a clockwise direction, that we can represent it upward arrow. And if that revolves in the anti-clockwise direction, we will represent it downward arrow. So to calculate the total spin of an atom, if you want to calculate the total spin of an atom, the formula, so that is a total spin of an atom, that is equal to n into 1 by 2. So n is here number of unpaired electrons. Number of unpaired electrons. Number of unpaired electrons. We want to calculate the total spin of an atom, that is equal to n into 1 by 2. That is a n is here number of unpaired electrons. Now we are seeing the significance of quantum numbers. So what is the main significance? So there are 4 quantum numbers. 3 gives information about the atomic orbital, explains that precisely atomic orbital, and 4th one gives information about the spin of the electron. So first principal quantum number, symbol n, values 1, 2, 3, 4, so on. So what is the significance? It will give information about the energy level. It will give information about the energy level or energy of the orbit. Energy level or energy of orbit. Next, another one, azimuthal quantum number, that is indicated with small l. The values of azimuthal quantum number, that is 0, 1, 2, 3 and so on, n minus 1. N minus 1. Next, another one, what is the significance? Azimuthal quantum number gives information about the shapes of the orbital. Shapes of orbitals. Next, magnetic quantum number, that is indicated with the m or ml. So values. So the values are minus l, 0 to plus l. So it mainly gives information about the orientation of the orbital. Orientation of orbitals. So the orientation of the orbitals will explain, and splitting that and explains the G1 and star effect also. And spin quantum number indicates with the small s or ms. So the values are plus of clockwise direction, minus of anti-clockwise direction. So what is the significance of the electrons, the spin quantum number? It will give information about the direction of spin of the electron. Direction of spin of electron. This gives information about the direction of spin of the electron. So this is the main significance of the quantum numbers. Quantum numbers are 4, principal, azimuthal. Next, magnetic quantum number, spin quantum number. So symbol n, principal quantum number, values 1, 2, 3, 4. Its significance mainly gives information about the energy levels and energy of the orbit. Next, another one, azimuthal quantum number indicated with small a. The values are 0, 1, 2, 3, n minus 1. Next, another one, magnetic quantum number, that is m or ml. Is it clear? So there is minus l, 0, plus l gives information about the orientation of the orbital. Here one thing we have to say that, so the orbitals we are having, what are those? P orbital. So it has the 3 p subshell, it is having 3 orbitals. D subshell is having the 5 orbitals. All are degenerated orbitals. What is the meaning of degeneration? So the orbital which are having the equal energies, that we call degenerate orbitals. Next, spin quantum number. It will give information about the direction of the spin of the electron. So that indicated with the s or ms, plus of or minus of, significance direction of the electron.